This is Precalculus Section 1.2 Day 1 Notes. Today we're going to start by reviewing our properties of exponents. These are the properties that you learned back in Algebra 1, again in Algebra 2, so this is all review, and I just want to remind you that these properties are on posters on my classroom wall. Our first property is the product of powers property, which says if you multiply powers with the same base, you add the exponents. So a number example would be, let's say we're going to take 3 squared and we're going to multiply it times 3 to the 5th. We have the same base of 3, so we're going to take our same base, 3, we're going to add our exponents, 2 plus 5, so this would give us 3 to the 7th. If you want to know what 3 to the 7th is, you can type that in your calculator. Power of a power property, notice that this contains parentheses. So if we have 3 squared, and then we're raising that to the 5th power, here's where we multiply our exponents. Remember, parentheses mean multiply. So our base remains 3, but now we're going to be multiplying 2 times 5. So this one's going to give us 3 to the 10th. These first two properties are often confused. Make sure you know when you add exponents and when you multiply them. Power of a product property. If we've got a product inside parentheses with an exponent on the outside, this is basically the distributive property of exponents. Everybody inside the parentheses gets that exponent. So let's say we have here 3 times 4 squared. Well, then we're going to distribute that exponent to both bases. So the 3 will get squared and the 4 will get squared. And again, you could simplify from there. We've got our negative exponent properties, and you can look at this a few different ways. If we have a base raised to a negative exponent, we can take that base, move it downstairs, and then the exponent becomes positive. For example, 3 to the negative 2 power, if we bring that base downstairs, it becomes 3 to the positive 2 power, and we could simplify from there. If we have a base with a negative exponent downstairs, we move that base upstairs, and its exponent becomes positive. So an example here would be if we had 1 over 3 to the negative 3rd power, that's going to be equivalent to 3 to the positive 3rd power, and now it's up in the numerator. And then the last one, if we've got a fraction in parentheses raised to a negative exponent, I like to use this trick a lot. You just take the reciprocal of that fraction, and then it becomes positive. Okay, so let's say we had 2/3 to the negative 2 power. Well, this is simply going to become 3/2 to the positive 2 power. And then we could go ahead and we could distribute that exponent upstairs, and we could distribute that exponent downstairs, and we could simplify from there. Our zero exponent property, anything raised to the 0 power is always 1. So if we have a base of 3 raised to the 0 power, we will have 1. Quotient of powers. If you've got the same base upstairs and downstairs, you are going to be subtracting your exponents. For example, if we have 3 to the 5th upstairs and we have 3 squared downstairs, then we're going to take 3 as our base. The base doesn't change. It's going to be 5 minus 2, so this is going to give us 3 cubed for our answer. Now, what if the exponent downstairs is bigger than the exponent upstairs? Well, we just do the subtraction downstairs. So for example, let's say we have 3 squared in the numerator and we have 3 to the 7th power in the denominator. So that's just going to be 1 over 3 to the 7 minus 2. So basically, wherever there are more of your bases, that's where your answer will result. In this case, we had more 3's downstairs than we had upstairs, so we're going to end up with 3 to the 5th in the denominator. And then finally, we have power of a quotient. So that says if we have a quotient, let's say 3/5 raised to a power, then our numerator gets that exponent and our denominator gets that exponent. So we're just going to distribute it to all bases in our expression. All right, so let's do some practice examples here. And I want to remind you that when you're working exponent problems, you can follow the exponent rules in any order that you want. And as long as you're following the rules, you should always come up with the right answer. So in example 1 here, we've got a whole bunch of parentheses. I just want to point out that the parentheses in this problem just mean multiplication. Notice that there are no exponents outside any of these sets of parentheses that require distribution to the bases inside, okay? So the very first thing I'm going to do here is I'm just going to separate this out and kind of put like terms together. So when I look at each of the things that I'm multiplying together, I've got 2 in the first one, I've got 1/4 in the second one, I've got 16 in the third one. Those are all coefficients. So I'm going to put those all first. So I'm going to write 2 times 1/4 times 16. Okay. Next, I'm going to put my c's together. So my first one's got a c cubed, and my second one's got a c to the 6th. And then I'm going to put my d's together. I've got a d to the -1, and I've got a d to the 4th. Okay. And now I'm just going to simplify everything at once here. I'm going to say, well, what is 2 times 1/4 times 16? Well, 2 times 1/4 would be 1/2, and half of 16 would be 8. So that's going to give me 8. Then I've got c cubed times c to the 6th. I'm multiplying powers with the same base, so I'm going to be adding my exponents. That's going to give me c to the 9th. And then the same thing with the d's. I'm multiplying powers with the same base. I've got d to the -1, and I've got d to the 4th. I could move that -1 downstairs, or I could just say, well, what's -1 plus 4? Because they have the same base. So that's going to give me d to the 3rd. Moving that d to the -1 downstairs just gives me d to the 4th over d to the 1st, which still leaves me with d cubed as my final answer. So there we go. All right, example number 2, we've got parentheses, and this time we do have some exponents outside the parentheses. So the first thing I'm going to think about is distributing that exponent 2 to the 2 and to the x, because there are 2 bases there inside the parentheses. They're both going to get squared. And then here, I'm going to distribute that 4 to the x cubed. And again, x cubed, that's x is the only base there. All right, so I'm going to simplify my numerator first. 2 squared on top is going to give me 4. X cubed squared, so remember, power of a power, we multiply. That's going to give me x to the 6th. And then I no longer need that parenthesis around the 3x to the 4th. So I'm just going to write a dot there instead. And then on the bottom, I've got 20. And then x cubed to the 4th power, power of a power. Again, we're going to multiply. So that's going to give us x to the 12th power. Okay. Now I could do a little more simplifying in my numerator. I can multiply 4 times 3. That's going to give me 12. And then I've got x to the 6th times x to the 4th. Powers with the same base, multiplying powers with the same base, you add. So that's going to give me x to the 10th upstairs. And I've got 20x to the 12th downstairs. I'm almost done. I just need to simplify top to bottom. Okay, so first let's look at our coefficients. We've got 12 over 20. That's a fraction that can be reduced. They have a common factor of 4. How many times does 4 go into 12? 3. How many times does 4 go into 20? 5. So I'm going to have a 3 upstairs and I'm going to have a 5 downstairs. And then I take a look at my x's. I've got x to the 10th upstairs and x to the 12th downstairs. Think subtraction, or I just like to think canceling. I think I've got 10 x's upstairs, I've got 12 downstairs. Where do I have more? Downstairs. Okay, how many more? Well, I've got 10 upstairs, I've got 12 downstairs, which that means I've got 2 more downstairs. So that means that I'm going to end up with x squared in my denominator. And I'm done with that one. 3 over 5x squared is my answer. Okay, number 3, I'm going to show 2 ways to do this, just in the spirit of showing how with exponent problems, there's more than one way to get to the right answer. It just depends on which order you do your exponent rules in. Okay, so option 1, I'm going to start by making my exponents positive. Okay, so I am going to, very first thing, I'm going to take care of this negative exponent right here. Okay, remember what we said about that if you've got a fraction and you've got a negative exponent outside, the easiest way to make that a positive exponent outside is just to flip everything over. So I'm not going to be changing the signs of everything. I am literally just taking my fraction and I am flipping it upside down. So my x to the 5th goes upstairs, my y cubed, and my z to the -4th. No signs are changing inside. The only sign that's changing is that -3 exponent outside. And then I'm going to have that x, y to the -2, z to the -3. Those are now going to be in my denominator. Okay, so now if I'm continuing on this course of making my exponents positive, anything that's a negative exponent, I am now going to move that base upstairs or downstairs. Okay, so if I think about what needs to be moved here, I'm going to be moving my z to the negative fourth, I'm going to be moving my y to the negative 2, and I'm going to be moving my z to the negative 3 because those all have negative exponents. Everything else is going to stay just where it is. So upstairs, I'm still going to have my x to the 5th and my y cubed, okay? But then I'm going to be bringing that y to the negative 2 upstairs, and it's going to become positive. And I'm going to be bringing that z to the negative 3 downstairs up, and that's going to be positive. Okay. Then in my denominator, I'm still going to have that x, but then I'm moving that z to the negative 4th from the numerator. That's now coming downstairs. And then don't forget your cubed outside of everything. Okay, now before I distribute that cubed on the outside, I'm going to combine my like bases together. Okay, so I'm just going to do some simplifying inside my parentheses. I'm going to say, okay, let's start with x's. Let's go alphabetical. I've got x to the 5th upstairs, and I've got x to the 1st downstairs. 5 on top, 1 on the bottom. So I cancel 1 on the bottom. I cancel 1 on the top. That's going to leave me with x to the 4th upstairs. Let's look at y's next. Both of my y bases are together upstairs. When you have the same base in the same place, you add the exponents. So y cubed times y squared is going to give me y to the 5th power. And then I take a look last at my z's. I've got 3 z's upstairs. I've got 4 z's downstairs. Think canceling. The most I can cancel is 3 because that's all I've got upstairs. So if I take 3 away upstairs, they're gone. If I take 3 away downstairs, then I'm still going to have 1 z left downstairs. Okay, now my last step here is going to be to distribute that 3 exponent to all of my bases. But keep in mind, everybody gets it, right? So I'm going to distribute it to everybody. So my final answer here, and again, when you're distributing an exponent, you are multiplying exponents. So I'm going to have x to the 4 times 3 is 12th power, y to the 5 times 3 is 15th power, and z right now is to the 1st power, so 1 times 3 leaves me with z cubed on the bottom. And there's my final answer. So I would have called this process starting with making all my exponents positive. Now another way that you could approach this problem, equally as good, okay, just a different approach, is to subtract our exponents. And we're going to think about taking the big exponent minus the small exponent. So sometimes our subtraction is going to take place in the numerator. Sometimes it's going to take place in the denominator, okay? Now I'm still going to begin with flipping my fraction over and making that 3 on the outside a positive 3, okay? So I'm going to start in the same place that I started the previous problem. I'm going to have my x to the 5th, my y cubed, and my z to the negative 4th upstairs. And I'm going to have x, y to the negative 2, and z to the negative 3 downstairs with that 3 outside. But this time I'm going to subtract exponents. So again, I'm going to look at my variables in alphabetical order here, okay? And I'm going to say, all right, let's start with x. I've got 5 upstairs, 1 downstairs. So my subtraction for x is going to take place in the numerator. So that's going to be 5 minus 1, okay? Then I'm going to look at my y's. I've got 3 upstairs. I've got negative 2 downstairs. So again, 3 is bigger than negative 2, so my subtraction is going to take place upstairs. So that's going to be y to the 3 minus negative 2. I see a little karate coming on here. We're going to have a chop chop there, right? Okay, and then we look at our z's. We've got negative 4 upstairs. We've got negative 3 downstairs. Negative 3 is bigger than negative 4. So the subtraction for my z's, it's going to take place downstairs. So it's going to be negative 3 minus negative 4. Chop, chop again. And we're cubed. Okay, so now when I do this subtraction, I end up with x to the 4th, y to the 5th, and z to the 1st, still all cubed. And then I'm at the last step that I was the previous way that I did this. So when I distribute that 3, I end up with x to the 12th, y to the 15th, over z cubed. So same answer, just 2 different ways to get there. Okay, my last example is actually much easier than my third example. Let's start with 4/9 raised to the 0 power. Anything